Hey guys, welcome to Pepcoding. So in this video, we are going to discuss another question of our arrays and string series, that is majority element 2. So this question is almost similar to my majority element 1, but there we have some different constraints. Okay, so I suggest you guys to solve that question majority 1 first, and then try to practice this question. Okay, so here. Okay, so here we'll be given an array of size n, and in that array we have to find those elements that have more than n by 3 frequency, and then we have to return them, those arrays, right? I hope the question was clear. I again repeat, we have to find all those elements that occur more than n by 3 times in that array, okay? And we have to return them in an array list, okay? So suppose this is my array A, B, C, A, D, E, C, A. Okay, so here my size of my array is 10. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, size here is 9. N by 3 is equal to 3. So here frequency of A is 4, so which is greater than 3. So A can be my majority element. Okay, so now let's suppose if I had C here and C here. Okay, C here and C here. So the frequency of C is also 4, right? Which is again greater than 3. So 3 can also be my majority element. So I have to return this A and C in my array list. Okay. Now comes the question, how many majority element can we have? In the previous question, majority element 1, we can have only one majority element, right? Let's say how? Why we can have only one majority element? Because in my array, if I had 1, 2, 3, 4, let's say my size of my array is 8. So if n by 2 is 5, n by 2 is 4. So element, let's say my A have frequency more than n by 2, that is it has frequency, let's say 5, B, C, D. Okay, so can I have more than one majority element in my array? No, because half of the part my majority element like cover, right? And one more part, right? So the remaining part is what? Remaining part is n minus the frequency of majority element, which is always lesser than my n by 2, right? So here we can have only like one majority element, because n minus n is here is 8, frequency of majority element here is 5. So 8 minus 5 here is 3, which is lesser than my n by 2. So it means I can have only one majority element in previous question. Now in this question, let's see how many majority elements can we have. So in this array, its size is 9. Okay, so here 9 minus frequency of A is what? 4, right? Frequency of A is 4, so half of the part remaining is 3. Now again 9 minus, now my size remaining is 5. Now 5 minus 4 is equal to what? 1. It means now only the array remaining size of my array is 1. So can I have any other majority element other than this 2? No. So if I have 2 majority element, can I have third majority element? No, I cannot. Let's see how. This is my array, and if I arrange this array in such a manner, let's say if I arrange this in this manner, A, 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 C, 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 E. Alright. So half, let me divide it in half, n by 3, n by 3. This is n by 3, this is n by 3, this is also n by 3. And if it were 10, let's say E was here. So it was, let's say it was not, it's not n by 3, it's only one part. Okay. So here it is n by 3. So my majority element will definitely cover a part more than n by 3, right? It can be a one part or two part, right? More than n by 3. Now again my second majority element is also containing a part more than n by 3, right? So here only the remaining part is 1, or it can be 2, right? It can never be greater than n by 3, because I have divided it in equal part, equal n by 3 part, right? So can I have any other element here? No, I can have only only one element or two element here, not more than 2, right? Not more than 2 element here, so that it cannot, its frequency cannot be 3 or greater than 3, because I have only two spaces. Now let's take example of an array of, let's say, size 13. Okay, let's erase this all. Let's say my array is like this: A, 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 A. All right. Then B, 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 B. I have two majority element, remaining part is, let's say, E. Okay, this is my majority element. N here is 13. N by 3 is equal to 4. Right? So, N by 3 is equal to 4. N by 3 part, which is equal to 4. This is also my N by 3 part, which is equal to 4. And this is my remaining part. So, the frequency of A is more than N by 3 part. Frequency of B is more than N by 3 part. Now, remaining N by 3 part contains only these three elements. Right? So, it means if I have two majority element in my array, I cannot have third element. I can only have two majority element, right? Not more than two. Or either I can have only one element, let's say 1, A. Or I can have only one majority element. Let's say my array would be like A, B, C, D, E, F, G, H, I, A. Okay, this kind of. So I have here one majority element. Or I can have zero majority element. My array can be like this A, B, B, E, F, G, H, I, J, K, L. Right? My array can be like this. So it means I can have zero majority element, one majority element, two majority element. Okay? Because here, as you saw, here, its frequency should be, its A's frequency should be greater than N by 4. Okay? So it should cover a part here. Now its B's frequency should also be greater than N by 4 here. So it is going to cover a part more than N by 3. Right? So this is not possible that I have more than two majority element. Okay? So I can have either 0 or 1 or 2 majority element. Alright? Okay, now let's discuss the approach, how we can solve this. Let's say I have 7, 5, 6, 7, 8, 5, 7, 3, and let's say 7. Okay, this is my array and its size is 9. N is equal to 9. N by 3 is equal to 3 here. Okay, so how am I going to solve this? Now, in the previous question, we had a value and we had a count. If I match this value equal to my value, I am going to, initially my count was 0 always, and I initialize my value to AR of 0. And I have started my loop from here in majority element 2. Okay, so here I check this value. If it's equal to my count, like in the previous question, we were making pairs of two distinct elements, right? So here, what we were doing, we were just checking if it's equal to my previous element. So we were going to increase count, and if it's not equal, we are going to pair this and decrease my count to 0, right? And then start from here. But here in this question, what we have to do, we will be making pair of three elements. So in this question, we'll be taking two values, value 1 and value 2. Okay, and then count 1 and count 2. Okay, so let's say this is my 7 and this is my 5. Okay, so let's say my initially value 1 is initialized to ARR of 0, count is initially 1. My value 2 is also initialized to any random value. Let's suppose I again initialize it with value AR of 0. My count 2 is 0. Let's say why 0? Because my count 1 is holding its frequency. Alright, my value 1 is already holding this value. I have just initialized this value just to compare this with this value. Okay, but the frequency of ARR 0 is not holded by my count 2. Okay, so it doesn't matter that much. It's just the initial condition. Okay, so we can assign this with any random variable. So here what am I going to do? I'm going to pair with three elements. So if I check this one, I start from here. I check this index value. Is it equal to my val1 or val2? It's not. So what am I going to do here? I am going to assign this value to my value 2, because my count 2 is not holding the frequency of any other distinct element, right? If it's not holding the frequency of any other distinct element, it means it's empty. So I'm going to assign this 5 here and I'm going to make it count 1. Okay, so now my value 1 holds 7. Now my value 2 holds 5. Okay, now I start from here. I check this value. Is it equal to val1 or val2? It's not. So I'm going to do what? I'm going to decrease both of these count and pair this 7 with this 6 and this 5 also with 6. It means I'm just making a pair of three distinct elements. Okay, then I'm going to start from here. Alright, so decrease its count becomes 0, decrease its count becomes 0. So as I check here, I check this. Is this value equal to my val1? Yes, it is. So I'm going to increase its count. Alright, its count become 1. Now I come here. Is it equal to val1 or val2? No, it's not equal to val1 or val2. But I'm going to check the count of my val2. So first my val2, my count of my val2 is equal to 0. So I'm going, it means my val2 is not holding any number, because my count2 is 0. Count is 0, it means it's not holding the frequency of any digit. So I'm going to assign this value to my val2. So it become equal to 8 and its count become equal to 1. Now I again come here, come to this 5 and then check if it's equal to val1, val2. It's not equal to val1 or val2. Then I'm again going to assign this, decrease this both of this count to 0, 0. And then make a pair of these 3. Okay, then I again start from here. I check if it's equal to my val1 or val2. It's equal to my val1, so it's going to increase the frequency count 1, right? I check 3. Is it equal to val1, val2? No, it's not. But my val2 is not holding any number, so I initialize it with 3 and initialize it count to 1. I check this value. Is it equal to val1, val2? It's equal to val1, so I'm going to increase its frequency to 2. Now I come here and my loop terminates. So here it means my val2, val1, that is 7, can be my possible candidate to be my majority element. Alright. So let me just write it in a very clear manner. All these conditions, what am I doing and when am I doing. So my array was 756, 785, 737. Okay. 7567, 85, 737. 7, 5, 6, 7, 8, 5, 7, 3, 7. 8, 5, 7, 3, 7. Let's take an example where I found two majority element. Let's say this is 7, 7, 7, 7. Let it make 5 and 5. So it is of size 11 now. Okay, 5, 5. So n is here is 11, n here is 11, and by 3 is 3. N is equal to 11, n by 3 is equal to 3. Okay. Okay. So my val1 is equal to 7 now. Count 1 is equal to 0, which is holding the frequency of my, count 1 is equal to 1, which is holding the frequency of 7. Okay. Count 1 is equal to 1. Val2 is initially just initialized with this value, but its count 2 is 0. It means it's holding the frequency of no element. I am here. I check if it's equal to val1 or val2. It's not. So I will be having conditions here. So first of all, I will check if my val1 is equal to my ARR of I. If it is, okay. If my val1 is equal to ARR of 5, if it is, then increase just my count 1. Alright. Else, if my val2 is equal to ARR of I, then increase my count 2. Right? Otherwise, both are not equal to the third element. It means both are distinct. Then I'm going to check. Is my val1 or val2 holding any number? Then I'll check, is my count holding count 1 is equal to 0. If it is equal to 0, it means my val1 is not holding any number, not holding the frequency of any number. So I'm simply going to assign my val1 to be equal to my ARR of I and initializes count 1 to be 1. Else if my count 2 is equal to 0, then val2 will become, I'll assign my value to val2 and initialize its count to be 1. Its count 2 will become equal to 1. Else both this val1 and val2 is not equal to my value. Okay, when my both val1 and val2 are not equal to my value, then we'll see what do we have to do. Okay, so let me just, okay, all right, we'll figure out then what do we have to do. Let me just erase it and make it more clear. Else condition says, else if my count 1 is equal to 0, then ARR of I will be assigned to my val1. Then my val1 will be assigned ARR of I. And count1 will become equal to 1. Okay. Else if my count2 is equal to 0, then my val2 will become equal to ARR of I and my count2 will become equal to 2. Will become equal to 1. Else will be the condition where both these elements are not 0 and either not equal to my current element. Then what am I going to do? I am going to make the pair. It means I will decrease its frequency, and its frequency, it means I am going to decrease both my count1 and count2. Decrease. What does that mean? It means, let's see, check this value first. Okay, I will check if this value equal to my val1 or val2. No, it's not equal to my val1 or val2. So I come in else condition. I'll check if the count1 0. No. Is the count2 0? Yes, count2 is 0. Initialize my value to AR or 5. Make this value to 5 and initialize this count to 1. I come here. I check the value. Is this value equal to my val1, val2? No, it's not. So it's not going to hit this condition, not this condition, not this condition, not this is not this if, not this else. Then it will come to this else. So it is going to add pair this 5 and this 7. It means it is going to decrease its count1, count2. It means this 7 will be paired with this 6 and this 5 is also going to be paired with this 6. It means the frequency of both are decreased to 0 now. Okay. Now I come here. I check if it's equal to my val1. Yes, it is. Increase its count to 1. So my val1 is 7. Count1 is 1 now. Val2 is 5. Count2 is 0. Alright. Okay. Now I come here to my 8. I check if this 8 is equal to my val1 or val2. No, it's not equal to my val1. Neither it is equal to my val2. But I'll check if the count of my val2 is equal to 0. Yes, it is, because my val2 is not holding any number. So I'm simply going to assign my val2 the value 8 and initialize its count to be 1. Okay. It means its frequency to be 1. Then I come to this 5. I check, is it equal to my val1, val2? It's not. So, and the count 1 is also not 0. Count 2 is also not 0. It means my val1 is holding some value and my val2 is also holding some distinct number, right? Both are holding distinct number. So I'm going to map this 5 with this 7 and with this 8. Okay. And decrease both of the count. So it becomes 0. Its count 1 becomes 0. Count 2 becomes 0. Now I come here. I check if my value is equal to my is my AR of I is equal to val1, val2. Yes, it is equal to val1. Increase the count. I check this if it's equal to val1, val2. No, it's not equal to val1, val2, but the count of val2 is 0. It means count 2 is not holding anything. So I make val2 to be 3 and initialize this count to be 1. I come here. Is it equal to val1, val2? Yes, it is equal to val1. So make the count 1 to 2. Okay. Now I come here. Is it equal to val1, val2? No, it's not. So I'm going to assign this 7 with this 5 and this 3 with this 5. I'll come here. I am going to decrease this counts. I'm going to assign this 7 with this 5 and this 3 with this 5. Right? Now I come here. I check if it's equal to val1, val2. No, it's not equal to val1, val2. But value 2 is not holding anything. So I make val2 to equal to my AR of 5, initialize this count, and then I reach here. So my 7 and my 5 can be my possible valid candidate to be my majority element. Alright. Then I call a method and then check if its frequency is greater than n by 3, and if its frequency is greater than n by 3, I'm going to add this to my array list. It means I'm going to add this to my answer. Okay, so let's try to code for this. First of all, I will be making my variables. First will be val1, which is initialized to ARR of 0. Second will be val2, which is initialized to ARR of 0. Count 1 will be equal to 1 and count 2 will be equal to 1. Okay. And then my n variable, which is equal to my ARR dot size. Okay. Now I'll run a while loop. While Let's make an I variable int I is equal to 0. Okay. While I is less than n, check if ARR of I is it equal to val1. If it's equal to val1, simply increase the count 1 plus plus. Okay. Else, if ARR of I is it equal to my val2, then simply increase count 2 plus plus. All right. Else, if it's not equal to both of them, then I'm going to check is any of the number is single, is like holding nothing. If any of the count 0, I'll check if my count 1 is equal to 0, then assign my val1 to be my ARR of I and count 1 to be 1. Okay. Else, if count 2 is equal to 0, it means value 2 is not holding any value. So val 2 will become to ARR of I. Then increase the count to be 1. Otherwise, we have condition when both are not equal to my ARR of I and both are holding some distinct value. Then do what? Map this to my ARR of I, that is decrease my count 1 and count 2. Okay, and then increase I plus plus. All right, now here let's make an answer. Let's name it vector of type int. Let's name it result. Okay, now I will check if I will call a method. It will check if the frequency is greater than n by 3. I will pass my ARR and my val1. Is the frequency of val1 greater than n by 3? If it's returned true, then do what? Then result dot push back push my val1. Again check if val1 is not equal to val2. It means val1 and val2 are two distinct values and value 2 has a greater frequency than n by 3. So check is greater than n by 3. ARR val 2. Okay, if it's greater than n by 3, then do what? Then add this to my answer. Dot push back val 2. Okay, and then return my answer. Okay, first of all we have to write is greater than n by 3 method. So initially I will be making a count which is initially equal to 0, which will hold the frequency actually. Okay, so I will start a loop for int I is equal to 0, I less than ARR dot size, then I plus plus. Okay, then I will check if my ARR of I is equal to my value. Whenever it's equal to my value, increase my count. Okay, and then in last return count greater than ARR dot size by 3. Okay, now let's try to run this code. There is some error, result dot pullback. Okay, 51 पे on line 51. It should be BACK back. Okay, now let's try to run this code. Accepted, and let's try to submit this. One of the two test cases failed. Let's see what happened. Let me just check if I have made some mistake or not. And is greater than n by 3. ARR val2 true. Okay, val1 val2 is I plus plus, count my 1 minus minus. Okay, count 2 should be 0 here. Initially my count 2 should be 0 here. Okay, then I'll check again. Okay, submitted. Correct answer. One thing that I was supposed to tell you guys, that was why am I checking if val1 is equal to val2 or not. So come here, let's see. If I were having an array like this, 1 1 1 1 1 1. Okay, so initially my val1 is 1, count1 is also 1, val2 is 1 and count2 is 0. Okay, I check this. If it's equal to val1, I increase my count. It's equal to val1, I increase my count. It's equal to val1, I increase my count. It is equal to my val1, I increase my count. It's equal to my val1, I increase my count. Okay, so when I check, when I call is greater than n by 3 frequency for val1, it returns me true, and I add this to my answer. So my frequency of val2, that is again equal to 1, and if I call the function is frequency of 1 greater than n by 3, so it also returns true. So my array list will contain now 1 1, which is a wrong answer. It should only contain 1. Okay, so that's why I'm checking if my val1 is equal to val2 or not. Okay, so okay guys, I hope I was able to make it clear to you guys. I hope you like this video, and if you like this video, please like, share and comment, and thanks for watching.